Hey guys, in today's video we're going to be taking a look at how we can solve integrals in the form of integration of f prime of x over f of x dx. And basically what this is saying is that we have a function and the derivative of that function is in the numerator and the actual function is in the denominator. And what is that equal to? Well, that is equal to natural log of absolute value of f of x, the original function, plus c. And that is all there is to it. So let's actually go right into the practice problems. So here is our first problem, integration of 2x plus 5 over x squared plus 5x minus 7 dx. When approaching these problems, it's also important to actually use u-substitution. And that is because u-substitution will actually simplify this integral to a point where you can then apply this formula. So u-substitution is going to be extremely helpful in all of this. If you don't know how to apply u-substitution, feel free to check out my video. I will link it in one of the corners over here. But other than that, if you do know u-substitution, let's get on with this problem. So in this case, I'm going to set u equal to the denominator, and you will see why in a second. So let u equal to the denominator, which is x squared plus 5x minus 7. I'm going to take derivative of both sides, so that's du equals 2x plus 5 dx. I'm going to find the value of dx. I know a lot of other people, they simply stop over here and then manipulate the original question so that they can apply this formula. But personally, I find it easier finding dx and then just plugging it in for the original equation. So that is how I'm going to proceed. So dx is equal to du over 2x plus 5. Now we have everything we need. We have this 2x plus 5 at the bottom, 2x plus 5 at the top. We're getting somewhere over here. I'm going to rewrite the original integral, which was in terms of x. I'm going to rewrite it in terms of u. So we have integration of 2x plus 5. I'm going to leave that there for a moment. And we said the denominator was u. And we said dx was equal to du over 2x plus 5. And you could see why I left that 2x plus 5 over there is because this and this got canceled. And now you're left with integration of u du. And automatically we know that this is natural log of u plus c. And substituting that, we get natural log of u, which we said was x squared plus 5x minus 7 plus c. But the interesting thing over here is that when we did this step right over here, we implicitly applied this formula over here. And let me explain why. This is because if we say that f of x is equal to u, and for the sake of this demonstration, let us look just over here. So everything is in terms of u. This theorem says that the original function has to be in the denominator, so our original function has to be u. And it says that the derivative of the original function has to be in the numerator. And if we take the derivative, we are left with 1. We're taking derivative with respect to u because we see that du over here. And this automatically means that we can apply this theorem because now we have f prime of x over f of x, and that is equal to 1 over u. And that is exactly what we have over here. And this is equal to natural log of the original function. Natural log of the original function was u. So implicitly, we just applied this formula, but this formula becomes extremely helpful when we have more complex problems. But either way, that is how. All right, so in our second problem, we have integration e to the power of 3 natural log of x times x to the power of 4 plus 1 to the power of minus 1 dx. Once again, we're going to apply u-substitution to simplify the integral first, and then we're going to apply this theorem in order to actually solve the integral. But first, I want to simplify this integral. I don't really like the -1 exponent, so I'm going to rewrite this integral as integration e to the power of 3 natural log of x over x to the power of 4 plus 1 dx. I know that I can also simplify the numerator by doing integration e to the power of natural log. Let me rewrite that. 1 second. Integration e to the power of natural log of x to the power of 3 over x to the power of 4 plus 1 dx. And I also know that I can further simplify the numerator by having integration of x cubed over x to the power 4 plus 1 dx. And that is because of our second hint at the top over here. We have e to the power of natural log of x is equal to x. In other words, e to the power of the natural log of any function is just equal to that any function. In this case, our function is x cubed, so that is just equal to x cubed once again. So now that we have simplified it fully, now we are ready to apply u-substitution. So I'm going to say let u equal the denominator, so x to the power 4 plus 1. Let us take derivative of both sides, so we have 4x cubed dx. We have dx is equal to 1 over 4x cubed du. We have integration of, I'm using this formula, or this integral right now. So I have integration of x cubed. I'm going to leave that there for a moment. And then denominator, I said that was u. Dx, we just found it up top over here. That is 1 over 4x cubed. We see that the x cubed and the x cubed are canceled. I'm going to take this 1/4 out. So we have 1/4 integration of 1 over u du. Simplifying this, once again, we are implicitly applying this formula right over here. We're left with 1/4 natural log of u. And putting in the value of u, we are left with 1/4 natural log of x to the power 4 plus 1, and of course, plus c. And that is our final answer. All right, so for our third problem, we have integration of 1 over 1 plus e to the power of minus x dx. Once again, I don't really like this minus x. I am going to rewrite this as integration of 1 over 1 plus 1 over e to the power of x dx. I'm going to once again simplify this, saying that this is integration e to the power of x over e to the power of x plus 1. I just took e to the power of x in the denominator. This is in the denominator of the denominator, so that goes to the numerator. So that is how I got e to the power of x up top, right over there. And of course, we have that dx. Now, I'm ready to apply u-substitution. So I'm going to say let u equal to e to the power of x plus 1. As before, du is equal to e to the power of x dx. dx is equal to du over e to the power of x. Now I'm going to simplify this right over here. So I'm going to take this over here. Integration e to the power of x over u, because u was the denominator. dx we found is du over e to the power of x. This and this cancel out. Once again, we're left with integration 1 over u du. We know this is natural log of u. Natural log of u. And replacing u, we are left with natural log of e to the power of x plus 1 plus c. Now we have our fourth problem, integration a over b plus c e to the power of x dx. And I will tell you this is more on the hard side, because we do have to apply something right before we get into u-substitution, and that is a hint I will give you. Don't apply u-substitution just yet. But if you want to give this problem a go, feel free, but I'm going to walk over the solution with you guys. So, hypothetically, if we did apply u-substitution first, what problem would we run into? Let's actually try it right here. So this is basically the wrong way, but let's see why it's the wrong way. The wrong way is to apply u-substitution directly. So if we have let u equal, I'm going to say let it equal the denominator. So b plus c e to the power of x. We have to take derivative of both sides. So we have c e to the power of x dx. I'm going to solve for dx. That is du over c e to the power of x. I'm going to put the original problem, everything in terms of u. So we have integration of a over u. We found the value of dx from over here. So that is du over c e to the power of x. And here is where we run into the problem. So this a and c, they're fine because they're constants. We could just take them out later. U and du is also fine. We're integrating with respect to u. But there's just this e to the power of x, and mainly that x exponent, because Everything is supposed to be in terms of u, and there's not much we can do to simplify it. In the previous problems, we were able to cancel that e to the power of x with something else, but in this case, we're not able to do that. So we know that this is the wrong method to go. Let's not apply u substitution just yet. Rather, let's actually divide the top and the bottom by e to the power of minus x, and you'll see why in a moment. So we have integration a times e to the power of minus x over b e to the power of minus x plus c dx. Now, in this case, let's try to apply u substitution. So we have let u equal, once again, the denominator, so b e to the power of minus x plus c. We have du is equal to minus b e to the power of minus x dx. I'm going to solve for dx. I'm going to solve it right up here. So dx is equal to du over minus b e to the power of minus x. I'm going to take this new function that we have, and I am going to keep it as integration a to the power e minus x. I'm going to leave that the same. Over, we said the denominator is u, so that's u. We found dx as du over minus b e to the power of minus x. And now we can cancel. So that cancels and that cancels. And we get integration of a over u times du over minus b. A and b are just constants. Let's take them out of the integral. We are left with minus a over b. Integration of u du. We know this is minus a over b. Natural log of u plus c. And replacing u for this value right over there, we're left with minus a over b, natural log of b e to the power of minus x plus c, and plus this constant. I'm just going to write constant because there's a plus c over here and there's a plus c over here as well. So just not to be confused with that. And that is our final answer. So that is it for today's videos. I really hope you guys enjoyed and learned a little bit more about the formula that we discussed. Once again, to recap, we should apply u substitution first in order to simplify the integral, and then we should apply that theorem we just talked about. Sometimes before applying u substitution, you need to simplify it a little bit, such as the negative exponents. In the last problem we saw, we needed to multiply both the top and bottom by e to the power of minus x. Small things like that will overall make the u substitution process easier, and hence applying the theorem also easier. So thanks guys for watching, and I'll see you guys in the next video.